Compton effect. Figure 1 shows such a collision. X-ray photon strike with the electron and electrons scattered in this direction and photons scattered in this direction. Photon scattered has less energy as compared to the incident photon. We can think of the photon as losing an amount of energy in the collision that is the same as the kinetic energy gained by the electron. If the initial photon has a frequency nu is associated with it and the scattered photon has lower frequency nu prime, then we can write like loss in photon energy, which is equivalent to gain in electron energy. H nu minus H nu prime is equal to kinetic energy. We know that the momentum of massless particle is related to its energy by the formula E is equal to Pc. Before we understood, before we understood that, just have a look the vector diagram of the momenta and their components of the incident and the scattered photon and scattered electrons. So this is scattered photon and this is scattered electron. So here horizontal and vertical component is h nu prime by c cos phi, h nu prime by c sin phi. For the scattered electron, the horizontal p cos theta and p sin theta. The energy by the formula is equal to Pc. Since the energy of the photon is h nu, the momentum P E upon c is equal to h nu by c. The collision momentum must be conserved in each of the two mutually perpendicular directions. The directions we choose here are that of the original photon and one perpendicular to it. One is the original photon, another is the perpendicular to it. Two directions. Original photon and other is the perpendicular to it. In the plane containing the electron and scattered photon. The initial photon momentum is h nu by c and the scattered photon momentum is h nu prime by c. The initial and final electron momenta respectively 0 and p for the scattered electron. Initial momentum and final momentum. So here initial momentum is h nu by c plus 0, h nu by c initial plus 0. The final momentum is h nu prime upon c, h nu prime upon c cos phi plus p cos theta for the horizontal component. And other is the perpendicular to this direction, initial momentum and final momentum. The perpendicular here is 0 and here h nu prime by c sin phi plus p sin theta, sorry, minus p sin theta. The angle phi is that between the direction of the initial and the scattered photon. Theta is between the direction of the initial photon and the recoil electron. Equation 4, 5 and 5, we can find a formula that relates the wavelength difference between the initial and scattered photon with the angle phi between their directions. So if we compare this Pc cos theta multiply by c and we can rewrite the equation. So Pc cos theta h nu minus h nu prime cos phi, similarly p into c sin theta h nu prime sin phi. By squaring of these equations and adding the new ones together, so This is a square, and cos square theta plus sin square theta is equal to 1. So p square c square. And similarly, this is h square nu square minus 2 h nu prime cos phi plus h nu prime square. We equate the two expression for the total energy of the particle. One is this, and other is energy and momentum equation. We know that the energy is equal to kinetic energy plus mc square, and energy is equal to root m square c raised to 4 plus p square c square. If we compare these two equations, so we can get p square c square kinetic energy square plus 2 mc square kinetic energy. And the kinetic energy is h nu minus h nu prime. So p square c square is equal to h nu square minus 2 h nu prime plus h nu prime square, this plus 2 mc square h nu minus h nu prime, this equation. So this equation and this equation, if we equate these two equations, so finally we get 2 mc square h nu minus h nu prime 2 h nu prime 1 minus cos phi. In terms of wavelength, equation it by dividing by the 2h square c square. So we got the mc by h nu by c minus a nu prime by c is equal to nu by c nu prime by c 1 minus cos phi. Since the nu by c is equal to 1 upon lambda, we can write this equation like this: mc over h 1 upon lambda minus 1 upon lambda prime is equal to 1 minus cos phi divided by lambda prime. The Compton effect is basically is lambda prime minus lambda h upon mc 1 minus cos phi. This equation was derived by the Arthur H. Compton in the early 1920s, and the phenomena it describes, which he was the first to observe, known as the Compton effect. Equation 9 gives the change in the wavelength expected for a photon that is scattered through angle phi by a particle of rest mass m. The Compton wavelength lambda c h by mc. So Compton effect is change in the wavelength lambda prime minus lambda is equal to lambda c 1 minus cos phi. And this Compton wavelength for electron, it is 2.426 into 10 raised to minus 12 meter, which is around 2.426 picometer. So here is the modern physics syllabus is over. Thank you.